All right, so the final section of chapter 8, section 8.6, is solving rational equations. Like I said, we're not going to do the inequality piece of it today, just the equation piece. And so let's jump right into solving. Let's do 2 over x plus 3 plus 3 over 2 is equal to 19 over 10. There are multiple strategies for solving these. You probably are well aware that if you have a proportion, like a single fraction equals a single fraction, that you can do cross multiplication to solve. And because that's true, most of these problems you can turn into problems like that. You'll notice right now you have two fractions on the left side and one on the right, so we can't just cross multiply right now, but you could combine a couple of them together. That is a strategy you can use. But what I'm going to promote, and I think it's generally, the general rule, a better approach. There are some exceptions to that, but is number one, I would recommend that we identify or find the least common denominator. So find the least common denominator. Then what I will do is I will multiply that least common denominator into the problem, both sides, every fraction, everything. Oops, I forgot an L there. All right, let's try that again. Multiply by the least common denominator. And then finally, from there, you can solve. And the advantage to solving after that point is we will no longer have fractions. When you multiply by the least common denominator, there will be no fractions remaining. And if we can eliminate fractions, then it's a lot easier problem to solve, I believe. So let's take a look at question number 1. And let's identify the least common denominator. It's not new. We did this when we dealt with addition and subtraction. We had to have a least common denominator. When we first said, make sure your denominators are factored. Well, x plus 3 doesn't factor. And then 2 and 10 are just coefficients or constants. So if you focus on those constants, 2 and 10, I would like not just a common number they both go into, but the smallest common, the least common denominator. So what do 2 and 10 go into? That's the smallest possible. 10 doesn't go into 2. 10. You can divide 10 by 10. I mean, you can, and you can divide 10 by 2. 2 goes into 10, 10 goes into 10. They both go into 20, they go into 40, things like that. But 10 is the smallest number they both go into. Additionally, we have another factor there, that's x plus 3. I need to include that as well. And that LCD covers the x plus 3, it covers the 2, it covers the 10, that covers everything. So that was step number 1. There's my least common denominator. I'm going to leave it in factored form. There's no advantage to distributing it, and probably makes it harder if you do. So number 2 is I'm going to multiply everything by the least common denominator. Here's what that's going to look like. I'm going to first expand out the problem. I'm going to kind of really stretch it out just so I have room to write that least common denominator. And I wouldn't necessarily do this every single time. But for today, I will, just so we can clearly see that least common denominator. So I have the 2 over x plus 3 plus, then I'm going to leave some space. Then I'll write out my 3 over 2, and then my equal sign, then I'll leave some space, and I'll put my 19 over 10. Okay, exact same problem, nothing's changed. But now I'm going to multiply each of those pieces by the LCD. And when we multiply by that, understand only the numerator gets multiplied by that. I didn't give it a denominator. If you want a denominator, if that helps you, then put them over 1. It's a good strategy, but please don't multiply them into the denominator. And now as I multiply each piece, think about your simplifying, the rules that we already have. In that first piece, the x plus 3 denominator cancels out with the x plus 3 factor. You will, on each of these, you better not have a fraction left. Your denominator should cancel. So what I'm left with then is the 10 times 2, which is 20. Then it was plus. Now I do the same thing with the next piece of this. The denominator of 2 simplifies with the 10 to turn the 10 into a 5. 5 times x plus 3 times 3. Well, the 5 times the 3, I'll probably multiply those together first to get a 15, and then I have the x plus 3 still. I will have to distribute that. If you want to distribute it right now, I would replace it with 5x plus 5. Let me try that again. 15x plus 45. Equals, and then the last piece, the 10s cancel, leaving you with the 19 times x plus 3. You can distribute that. 19x plus 57. If I clean up the left side a little bit, I get 15x plus 65. And at this point, I have an equation, no denominators, move all the x's to one side and the non-x's to the other side. So I would subtract 15x from both sides. So I end up with 4x on the right side, and that means I would subtract 57 away, giving me 8 on the other side. So 4x is equal to 8, divide by 4, and we see that x is equal to 2. It is important, since we're dealing with rationals, and they do have domain restrictions, that you make sure that your answer works. Namely, we're trying to make sure that we have an answer that does not make 0 denominators. If you plug that into the original problem, do we get any 0 denominators? No. So this one actually works out. But sometimes we'll have problems that don't work. Let's jump into another problem. Let's go with 2 over z plus 1 minus 1 over z minus 1 equals negative 2 over z squared minus 1. We want to identify the least common denominator, and first make sure your denominators are factored. In this case, we need to do a little bit of factoring. Z plus 1 doesn't factor, that is a factor. Z minus 1 also is a factor, but then z squared minus 1 factors to z plus 1, z minus 1, which means it overlaps with the other denominators. That's important to recognize. So the least common denominator. The first denominator had a z plus 1 factor. I'm going to need to include that. Second denominator had a factor of z minus 1. That's unique and it's different than z plus 1, so I have to include it also. Then when I get to the last fraction, I already have that entire denominator covered. So there is my least common denominator. So I'm going to be ready to multiply that in. So I'm going to extend this out, expand it out so I have some room again. Okay, so I took the exact same problem, simply expanded it out to make room for my least common denominator. And so then I wrote my least common denominator in front of each of those pieces, multiply it out. We have some simplifying to do. In the first fraction, the z plus 1 will cancel. So you'll be left with z minus 1 times 2. Go ahead and multiply that or distribute. 2z minus 2. And the next one, z minus 1 cancels. So we're left with 1 times z plus 1. But be extra careful because this was subtraction. And that subtraction is really going to distribute to that entire thing. So when you take 1 times z plus 1 and get z plus 1, you're actually subtracting both of those. We have to distribute that in there. So it's minus z minus 1. If I confused you on that piece, here's what I would recommend. Group that negative with the denominator or the numerator that was already there. So it was a negative 1. Go ahead and write down negative 1. And then you're multiplying in z plus 1. And then you're going to distribute that. So if I lost you on where my signs came from, that's really what happened. I distributed negative 1. Negative 1 times z is negative z, and negative 1 times positive 1 is negative 1. Then continue on from there. The last fraction, the z plus 1 cancels, so does the z minus 1, leaving us with negative 2. Clean up the left side. Z minus 3 is equal to negative 2. Add 3 to both sides, giving us z equals 1. Does that answer work? No. If you plug that into the original equation, check out the denominators. First denominator is okay. 1 plus 1 is 2. Second denominator, 1 minus 1, 0. We would have 1 over 0. That's a problem. If you looked at the last fraction, that would also equal 1. Or sorry, equal 0. Another problem. So z equals 1 doesn't fit in the domain. It's like an asymptote, so I have to throw it out. There were no other answers, so you would simply say there is no solution. And we're going to do one last example. That will be the end of our notes for today. For our last example, we're going to take a look at 7n over 3n plus 3 minus 5 over 4n minus 4 equals 3n over 2n plus 2. Our first step is to find the least common denominator, but before we do that, we should check to make sure those denominators are factored, because in this case there is some overlap, but if you look at it initially, it seems like they're all unique. But if you factor out the 3 from the first one, you get 3 times n plus 1. From the second, I can factor out 4, leaving me with n minus 1. And the last one I can factor out at 2, leaving me with n plus 1. And now I see there are some factors that overlap. So let's identify that least common denominator. Since we have some constants or coefficients this time, I would focus on those first. 3, 4, 2. What is the smallest number that can be divided by 3, 4, and 2? 12. It is 12. Then look at our other factors. N plus 1, we're going to have to include that. The next one has an n minus 1. That's unique. I need to include that as well. Last one has n plus 1, but I've already included that, so I don't need to include it again. It's overlapping. So here is the least common denominator, 12 times n plus 1 times n minus 1. I'm now ready to multiply that in. So let's expand out our problem. Here I see another subtraction problem. Maybe I want to right now deal with that subtraction problem and think of that as a negative 5. So I can turn this into an addition problem. If I put the negative with the 5, I can call it a negative 5 up there. I like that idea better. And my denominator is 4 times n minus 1 equals 3n over 2 times n plus 1. And we're multiplying in our least common denominator, our LCD. And now we can start simplifying. First fraction had an n plus 1, I can cancel that out. But it also had a 3, so I need to simplify that with the 12. 3 goes away, 12 becomes a 4. So 4 times n minus 1 times 7. And I would multiply the 4 and the 7 in together right away. Get 28. But then I also have an n minus 1 factor. I will need to distribute that. Maybe I'll wait for a second to do that distributing. I'll just continue the problem, and then I'll come back to that. Next part, n minus 1 cancels, and the 4 goes away, changing the 12 to a 3. So I have a 3 times n minus 1 times negative 5. So 3 times negative 5 makes negative 15 times n plus 1 equals, and then in the last one, n plus 1 cancels. 2 simplifies with the 12, turning the 12 into a 6. So 6 times 3n is 18n, and then I have n minus 1. Now let's do our distributing. 28n squared minus 28n. Here I'll distribute the negative 15, so I get minus 15n. I went ahead and left out the plus since I knew it was going to be subtraction. And then negative 15 times 1 is minus 15. Equals, distribute your 18n. 18n squared minus 18n. From there, I can clean up especially that left fraction, or left side of the equation. Okay, and now as I go to solve this, I recognize that there's n squareds in here and n's and constants. So we're going to have to solve this probably by factoring. And when we solve by factoring, we want it set equal to 0. So we're going to move everything to the same side. So I will subtract away 18n squared. And I will add 18n to both sides. So we get 0 on the right side, 10n squared minus 25n minus 15 is equal to 0. Now I need to factor to solve that, but I do notice that I can divide out 5. I can factor out 5. And at that point, 5 times that expression equals 0. The only way that expression equals 0 is if 2n squared minus 5n minus 3 equals 0, because 5 doesn't equal 0. So I can really ignore that 5. and this part has to equal 0, and then solve that. Factor that. Now, depending on who your teacher was first semester, also, you learned to factor this back in Algebra 1, as well as again in Algebra 2. So there's a lot of different strategies that are shown. And I don't care which way, what strategy you use, as long as you can get it factored. So factor it however you prefer. But we should end up with 2n plus 1 and n minus 3. Then set each factor equal to 0. And then solve to get your answer. So 2n is equal to -1. Divided by 2, you get -1/2 for one of your answers. And then the other one, you get n equals 3. So those are my answers, assuming they work. To check to see if they work, I go back to the original problem. After I had them factored, take a look at those denominators. The only ones that had n in them were like n plus 1 and n minus 1. So the only asymptotes are -1 and +1. I can't have -1 or +1, but I didn't get -1 or +1. I got -1/2 and I got 3. So both of those work. We actually have 2 answers to this problem. And that concludes the notes. I should mention, in case anybody printed off a calendar earlier in the semester, that we did change the assignment from what was originally there. If you check Canvas now, Canvas is accurate, but if you have an old copy of the calendar, here is what the assignment will be. Here's what I want you to do. Page 576, numbers 3, 4, and 18 through 21. That is the modified assignment based off of the portion of the section that I taught.